Hello students, Assalamu alaikum. We are doing lesson number 3. Today is the lesson number 3 of operating system, and we are doing the topic of memory management. And in previous lesson, if you see, we have seen the definition of memory management, and we have seen that a generated process might be stored fragmented in memory. Keeping track of these fragmented parts, their addresses, and storing in physical memory frame is called memory management. Then we also have seen that what is memory optimization, how and where a process should be stored in the best way in memory when a number of processes are competing with each other. Then we have seen that when a process is generated, that is not stored in contiguous way, rather it is stored in fragmented way. So single allocation in memory is not possible, right? That is divided, program is divided into a number of parts, and then those parts are stored in memory frames. To how to divide those memory parts, that is in form of paging and segmentation. So either paging technique is used or segmentation technique is used. Both are used to divide process into divisions and load in physical memory. Then we have seen paging. Paging is the process uh, in which process is divided into a fixed size divisions called pages using virtual memory. What is virtual memory? Virtual memory is the extension of physical memory, that is RAM, and a part on hard disk drive is reserved as an extension of the physical memory because of its limitation. So your hard disk drive is used as a RAM, and some part of the process or program is stored on virtual memory, and from virtual memory, whichever page is required, that is loaded in memory. What is page offset? Page offset is the size of the page. Then we understood the concept of page table. A page table, uh, a table in which mapping addresses of page on logical memory and corresponding frame addresses are stored. Uh, then we have seen the diagram which is given in your book, in which virtual memory and physical memory has been shown, and between them page table has been given, where page number and page frame numbers and presence flag. Presence flags means whether the page is loaded in the memory or not. Then we have understood the concept of swapping in, swapping out. Swapping in means page is being loaded in the memory, and when the need of the page is not there in physical memory, then that is removed from the memory and the new page is loaded. So removing from the memory is called swapping out, and loading the page from the virtual memory to the main memory is called swapping in. Now in today's class, today is the lesson number 3, we are going to discuss the concept of segmentation. Concept of segmentation is similar to paging. Let's see the definition. It is similar to paging concept. In paging, pages are of same fixed size, while in segmentation, pages are or the segments are of variable sizes. So let's see the problem. In paging, what happens? For example, this is a program, and you know that a program might consist of a number of functions: function 1, function 2, function 3, and function 4. But when this program is divided into pages, and pages are existing in the virtual memory of the hard disk, then it is not taken care of that one function is kept into one page. because pages are of fixed size, then quite possible function 1 is existing in page number 1 and page number 2. And similarly, because function 2 is a larger one, it might be existing in page number 2, page number 3, and page number 4. Similarly, function number 3 is in page number 4 and page number 5. And the last function is function number 4, because this is the smallest one. That's why quite possible it might be existing only in one page, that is page number 5. So this is how it is quite possible that a program is divided without taking care of its modules, its procedures, or its function. When these pages are allocated in physical memory frames, then they will be further scattered. So this is one of the problems which we face when the paging technique is used. The solution of this problem is segmentation. What is happening in segmentation? This definition I have taken from your book. Segmentation, where a large process is divided into segments for loading into memory, but the segments are not constrained to be the same size. Here the pages are of same size, but in case of segments, quite possible segments are in variable size. In paging, what is happening? Where a large process is divided into pages which have to be the same size, as we have seen in the previous example. So this illustration has been given in your book. As you can see, segment 1, segment 2, and segment 3, this is a program, right, or process. It has been divided into 3 segments, and you can see they are of different sizes. And this is physical memory. In physical memory, it has been divided into frames, and between them, just to keep the address of segment number and the memory address, the frame numbers, segment map table is being used. So segment number 1 has been kept at the address of 1000. 1000 is the starting address of physical memory, and because the size of the segment is 400, that's why you can see each size of the each frame size is of 100 size. So because size of the segment is 400, that's why 4 frames have been taken, 1 2 3 4, and this is in contiguous form according to your book. Then segment 2, this is the address of segment 2. Size of the segment is 700, and memory address, starting address, is 1400. So as you can see, this is 1400 address, 1400, 1500, 1600, 1700, 1800, 1900, 2000. So because the size of the segment is 700, as you can see, it has taken 700 addresses, 1 2 3 4 5 6 7. Similarly, the last segment is of 200, and the segment number is 3, and the starting address of this segment is 2100 address. So it is starting from 2100, and the size of the segment is 200. That's why it has taken 200 addresses of the physical memory. Rest of the addresses are free. So in physical memory, it is in contiguous form, and the size of the segment is variable. So this is the concept of segmentation. Now, because of the paging, because in paging we have seen that the process is divided into a number of frames. Normally paging is used, and because of this paging, the process from the memory are swapping in and swapping out. Pages from the memory are swapping in and swapping out. Swapping in means pages are being loaded in the memory, and swapping out means pages are being taken out from the memory. So because of this, a problem occurs that is called disk thrashing, and usually this is with the combination of when obviously hard disk drive is being used, and on hard disk virtual memory is being made for paging, right? So from the hard disk where virtual memory has been made to keep the pages, and in physical memory frames are there where pages are loaded. When page is loaded, that is called swap in. When page is taken out, that is called swap out, right? So if there is a lot of swapping in and swapping out, then there will be overworked done by the hard disk drive. And you know that hard disk drive is made of a number of platters, a number of platters, and there is a head which is writing data on it, something like this. So if there is a lot of swapping in and swapping out, then head movement will be a lot there on the hard disk drive platter. So because of this reason, there may be malfunctioning on hard disk drive. Your hard disk drive may crash. So this problem may occur, and this is the disadvantage of virtual memory and paging. Now we are going to see another concept of fragmentation. Fragmentation I have already discussed. What is the meaning of fragmentation? Fragmentation is when most of your memory is allocated in a large number of non-contiguous blocks or chunks, leaving a good percentage of your total memory unallocated but unusable for most typical scenarios. Now we have to see different types of fragmentation. There are two types of fragmentation: internal and external. What is internal fragmentation? It happens when memory is divided into fixed size blocks, leaving unused space by the process as a whole block of memory is allocated to one process. Because when the memory is divided into a number of blocks, and all the blocks are of fixed size, so the process which is being stored in the memory blocks, they are of different sizes, and one block has been reserved for one process. So quite possible there will be some space, as you can see in the picture, in the image, that some of the space might be left unused. So that unused space cannot be allocated to other process. Here you can see in the image there are four processes: P1, P2, P3 and P4, and they all are of different sizes, and the memory has been divided into four blocks of 4 MB each. So process 1 is coming in first block, leaving 2 MB unused. Similarly, process 2 is coming in second block, leaving 1 MB unused. Process 3 is coming in third block, leaving no space unused. Full space has been used. And P4 is coming in block 4, leaving 3 MB unused. So if P5, for example, P5 is required to be loaded, and it requires, for example, 5 MB. Now 5 MB is there in the memory. 3 plus 1 plus 2. 3 plus 1, 4. 4 plus 2, 6. 6 MB is free at present. 6 MB is free. But it cannot be loaded because the space is not contiguous, right? And one block cannot be shared by two processes. So this causes internal fragmentation, right? Now the solution of this problem is that the memory is divided into variable size blocks according to the requirement. As you can see, P1 requires 2 MB, so memory, this is physical memory in this situation. Physical memory. Physical memory, and here this is physical memory. Physical memory has been divided according to a requirement. P1 requires 2 MB, so 2 MB block has been made. P2 requires 3 MB, so 3 MB block has been made. P3 requires 4 MB, 4 MB block is there, and P4 requires 1 MB. So according to the requirement, the blocks have been made. But the problem is, you know that after some time when the process is not required or the program is not required, that is taken out. So for example, P2 and P4 both are not required. So P2 has been removed and P4 also has been removed, leaving 3 MB and 1 MB blocks. But these 3 MB plus 1 MB, 4 MB memory which is free right now, that is not contiguous. Now when the other block requires to be loaded, for example P5 which requires 4 MB, right now 4 MB is there free, but it cannot be loaded because the space is not contiguous. So similar problem is there. Process 5 or P5 cannot be loaded here. This situation is called external fragmentation. So in both cases, the spaces or the free spaces are there in the memory, but they cannot be used. So what is external fragmentation? It happens when variable size block of memory are allocated to processes dynamically, and the memory cannot be allocated to process because of non-contiguous division. Right? After this, we have to see another concept of page replacement. Now we have understood that from memory, pages are being swapped in and swapped out. So when a page needs to be taken out, what is the procedure, what is the algorithm, what is the method to be followed, what is the SOP to be followed, that how we can remove any page and the other page can be loaded in that situation. So for this purpose, some algorithms are used and they are given in your book. First one is first in, first out. Second one is optimal page replacement. Third one is least recently used process. And the fourth one is clock page replacement algorithm. So these are 4 algorithms which are used, and these algorithms we are going to discuss in the next class also. In next class, inshallah. So we end our lesson here. In today's class, we have discussed a number of things. Let's have a quick recap. We started from segmentation. Then we have seen that in segmentation, process is divided into memory, into variable size parts, and they are loaded in the memory. For this purpose, segment map table is used. Then we have seen the concept of fragmentation. In fragmentation, we have seen 2 types: internal fragmentation and external fragmentation. Then after this, we have seen disk thrashing and what is happening when there is a lot of swapping in and swapping out, keeping the concept of hard disk drive and virtual memory. So after this, we have seen page replacement, and for page replacement we have to follow 4 algorithms. So we end our lesson here. Inshallah, in next class we will start from page replacement, and we will see the first algorithm, first in, first out. Thank you very much.